Hello, geometry. 11.7, surface areas and volumes of cones. So the last lesson was just the volume of pyramids. One before that, the volume of prisms and cylinders. This one's going to look at cones. And then the last lesson looks at spheres, surface area and volumes of spheres. So cones are unique in that you take a circle. If you divide it into 6 equal parts, or however many you want. If you research any of those radian measurements, you notice there's 6 pi radians in a circle, and you have 6 pi's in this case. They cut out one piece, they stick it together, and you get a cone here. Okay. So surface area and volumes of cones, a couple formulas, mostly examples that we're working at here. When we're dealing with the volume, it's going to be very similar to the volume of a pyramid, in that a pyramid is related to a prism. Okay, you have square prisms, you have square pyramids. You can have triangular prisms, you have triangular pyramids. A cone is very similar to a cylinder. Okay, now the volume for a cylinder was area of the base times the height. Now the base was a circle, so volume was pi r squared times the height. So here's that same picture. If you take a cylinder with the same base as what a cone has, 3 of the cones would fill up the cylinder. So the volume for a cone would be 1/3 of pi r squared h, 1/3 of the base times the height. Or you take pi r squared h, divide it by 3. Okay, so there's your formula for the volume of a cone. For the surface area of the cone, it gets a little bit trickier. Surface area here is pi r squared plus pi r L. So a new one here is the L is the slant height that we're seeing here. It is not the altitude. Okay, so the L, that is the slant height. So this brings up a lot of questions a lot of times of Pythagorean theorem, because if you draw a slant height of this cone, you get a right triangle there. So that will come into play some of your questions here. The L is the hypotenuse. So we could say r squared plus h squared equals L squared. Or L would be the square root of r squared plus h squared. Okay. So going back to surface area, the surface area would be pi r squared. This is your base. And this right here is your lateral surface. Okay, that's the vocab word up above. That's your lateral surface. That's what's going around the outside of the cone. It's not the base. It's not the bottom. Okay, if you think of a megaphone is almost a cone. Okay, it'd be where the megaphone is. It's not the end that's open on the megaphone. That looks kind of weird. Okay. Anyway, haven't gone off topic with you kids in here. Haven't gone off topic as much. Let's remember that for future years. There's your volume of a cone formula. And here we go. Find the surface area of the right cone. So we have a 3, a 4, and a 5. Okay, 3, 4, 5 is one of our Pythagorean triples. Our surface area is pi r squared plus pi r L. So this is r. The 3 is the r, that's the radius, and this one is our L. We will not use the h for the surface area of the cone. So pi times 3 squared plus pi times 3 times 5. So S is going to be 9 pi plus 15 pi. So surface area would be 24 pi, which becomes, 24 pi, about 75.40. And that would be square centimeters. Surface area is in square centimeters. Okay. Volume, your units are cubed. It's units cubed. Okay. For your surface area, it's an area, so it's units squared. It's square areas, square units. A right cone has a diameter of 1.8 inches. So here's my cone. The back of it. My diameter is 1.8 inches and a height of 3 inches. So that's telling us the height right here. This is 3 inches. That makes this 0.9 inches. So we need to find the slant height. The slant height is the square root of r squared plus h squared. So So that's the square root of 0.9 squared plus 3 squared. Let's see if that's a nice clean number. Square root of 0.9 squared plus 3 squared. No, it's not. It's about 3.132. 092. Okay, carry some extra digits right now, or keep this exact number in here. Okay, so we want to take here, our surface area is pi r squared plus pi rl, pi r squared plus pi rl. So that's pi times 0.9 squared plus pi times 0.9 times the square root, what was 0.9 squared plus 3 squared? What's that? Ooh. Of 9.81. That was 9.81. So I just did this part to get that number. 0.3 squared plus 0.9 squared plus 3 squared. Okay. So let's figure what that is. So I have 0.9 squared times pi. That's that, plus 0.9 times the square root of 9.81 times pi. We get about 11.4. And that would be square inches, 11.4 square inches. Okay, so again, Pythagorean theorem used to find the slant height. You have to use the slant height for that. Find the volume of a cone. Volume of a cone. So volume is 1/3 pi r squared h. Now h is using this one right here. So volume is 1/3 pi times 3 squared times 4. Okay, so volume is 1/3 times 9 times 4 times pi. Rearrange it, 1/3 of 9, that'd be 12 pi. So volume is 12 pi square centimeters. And 12 pi is 37.70. 37.70 square centimeters. A right cone has a radius of 5 feet and a slant height of 13 feet. Okay, so we have a right cone, not a wrong cone. And we have a radius of 5 feet right there, 5 feet. And a slant height of 13 feet. Now for the volume, we need to know this height right here. So using Pythagorean theorem, h would be the square root. That is, 13 is hypotenuse, so I have to take 13 squared minus 5 squared. You should get 12. 5, 12, 13, that's one of our Pythagorean triples. So if you have a 13 and a 5, 13 is hypotenuse, the other one is going to be 12. So volume equals 1/3 pi r squared h. So that'd be 1/3 times pi times 5 squared times 12. Okay. So if I take 25 times 12 times pi, divide that by 3, that should give me 100 pi, about 314.16. 314.16 square cubic feet, cubic centimeters earlier. We're doing volume. It'd be cubic. Okay, find the indicated measure. A right cone has a surface area of 440, so that's our S, square inches, and a radius of 7 inches, R. Find the slant height, which is L. So S equals pi r squared plus pi rl. So 440 equals pi r squared, r is 7, so that's 49 pi plus pi rl, so again 7 pi times l. So first thing we're going to do is subtract this 49 pi. Okay, and again, keep these numbers in your calculator, do not round until the end of the problem. Okay, so I have 440 minus 49 pi. Yep, you're right. Okay, so I'm going to write this down, but I'm going to keep this number in here. So I get 286.06 equals 7 pi L. Now I'm going to have to divide by 7 pi, So I'm going to hit divided by, bring up my last answer, 7 pi. And we get 13. So that was 13. Okay. 7, 10, 13 is a Pythagorean triple. If our radius is 7, there's our slant height is 13. No, it's not 169 minus. No, it's not. Never mind. Scratch that. Okay. That'd be the square root of 120 for your height. A right cone has a volume of 528 cubic meters and a diameter of 12. We don't want diameter, we want radius. Radius is 6. Find its height. So volume equals 1/3 pi r squared h. So volume, which is 528, so 528 equals 1/3 times pi times r squared, 6 squared, and then h. So 1/3 of 36 is 12, so 528 equals 12 pi times h. So h is going to be 528 divided by the 12 pi. So 528 divided by 12 pi gives us 14. So h equals 14 meters. That's a big cone. Diameter of 12 meters and a height of 14 meters. That'd be, well, about 45 feet probably. That is a tall cone. Okay, cone A and cone B are similar, so similar shapes, what we've seen before. The radius of cone A is 4 centimeters. The radius of cone B is 10. So we have these two cones, and this radius equals 4, and this radius equals 10. The volume of cone A is 134. Volume is 134. Find the volume of cone B. Okay, they want volume, so we have to cube our scale factor. If they wanted the surface area, we would have to square our scale factor because area is squared. So our ratio here is 4 to 10, which reduced that to 2 to 5. So this is for our sides. For the volume, our ratio is 2 cubed to 5 cubed, which is going to be 8 to 125. That means for every 8 cubic centimeters we have on the smaller one, we have 125 cubic centimeters in the big one. So 134 over 8 equals x over 125. Okay, 134 over 8 equals x over 125. So this scale factor, for every 8 we have here, we have 125 over here. So 134 over 8 equals x over 125. So 134 times 125 divided by 8, we get 2,093.75 cubic centimeters. Okay. Find the volume of the composite solid. Okay, so we have a cylinder and we have a cone. So we just have to find the volume of the cylinder. Volume of the cylinder. And add the volume of the cone. Volume of the cylinder. So if our radius is 2, r equals 2, volume of the cylinder would be area of the base times height. So pi r squared times height plus the volume of the cone is 1/3 pi r squared times height. So this would be pi times 2 squared times 5 plus 1/3 pi times 2 squared plus 4. So this is 20 pi plus, times 4. 16/3 pi. So 20 pi plus 16/3 pi. About 79.59. And we are in cubic inches. Okay, that's the end of those examples. That's bottom of page 348. We have one more lesson remaining in chapter 11, and we're done with chapter 11. Your assignment to review is starting off with some surface area questions. Make sure you use the radius, not the diameter, on number 2, and then some word problems with surface area. Again, on the 4, they give you the diameter, not the radius. Make sure you cut that in half. 5, 6, 7, and 8, we're all dealing with volume of a cone. 9, you're starting to get into parts that are missing. Okay, so they give you the surface area. They want you to find the slant height, find that part first, and then use Pythagorean theorem to find the height of the triangle. Find the radius of the cone if they give you the volume, and then the similarity questions and composite figures. Okay, this one is a subtraction. They've taken a cone out of a cube. So find the volume of the cube and subtract the volume of the cone. So that is it for 11.7. Good luck. Anything trip you up, let me know. I'll be sure to help you and give you any direction I can with that. So we'll see you later. Hopefully see you soon. Talk to you later.